Hey everyone, hope you guys enjoyed your weekend and are ready for some more chemistry labs this week. So, what we're doing this week are ionic reactions, and the story behind it is there's an instructor who came across a few unlabeled bottles, which we talked about why that was important, that you need to label everything. So he came across a few, and so he's having a lab assistant mix some known solutions in with the unknown solutions and see what reaction occurs. And hopefully they can be able to identify some of the unknown solutions. So there are four ways that they're going to be able to identify if a reaction occurs. One of those ways is a change in temperature. Now we observed a change in temperature when in the third lab when we mixed the ammonium chloride and the water together, and that was a decrease in temperature, so that was an endothermic reaction. Now you can have the opposite effect, and you can have an exothermic reaction where the test tube or the beaker may become hot when adding two solutions together. Another reaction that we noted was with zinc chloride or zinc and hydrochloric acid. When mixed together, they formed hydrogen gas. Now that's another reaction. Now you can note that either by smell, or you can note that by the formation of bubbles within your solution. So that was two ways that we've already observed a reaction change. Now a third way is a change in color, which we noted when I did the demonstration with lead iodide and that precipitation. So when two clear colorless solutions came together, they formed a yellow precipitate. Now that's three ways we've observed a reaction occurring. The fourth way is a formation of a precipitate. Now, in that same reaction with the yellow precipitate, we've had two indications, a change in color and the yellow precipitate. Because had we let it settled out, we would have had a yellow precipitate at the bottom of the test tube and then a clear solution towards the top of the solution. So those are the four indicators that you're going to be looking for about if a reaction occurred. And so there are a couple different reactions that we're going to be looking at. So there is a precipitation reaction. So you have an aqueous solution, two aqueous solutions. When mixed together, they make another aqueous solution and a solid, just like we talked about with the lead iodide. You have an acid-base neutralization, where you add a acid such as HCl or hydrochloric acid, and you add a base such as potassium hydroxide. When mixed together, they're going to make a salt, so potassium chloride, and water, so H2O, and that makes water as a liquid. Then there's a redox reaction, and that's when you have two reactants. One of them is going to become oxidized, and one of them is going to become reduced. And as you've learned in lecture, Leo the line says GER, so losing electrons is oxidation, and gaining electrons is reduction. So you're going to be looking at that type of reaction as well. So you've also learned in lecture about the molecular equation. And the molecular equation of the solutions that you're going to be working with are basically given to you. You just have to balance them, and then you'll be able to go to the complete ionic equation and then to the net ionic equation from there. So you've already covered this in lab, so we're not going to go into very much depth with it. But with the net ionic equation, you're looking to take out all of the spectator ions, so that way you know exactly what is participating in the reaction and is producing one of those four signs that we talked about: the formation of gas, the change in color, the change in temperature, or the formation of a precipitate. So what you're going to do is, if you look at your page 86, you'll notice that there is a box set up for you, and you're going to add them in a specific order. The way you're going to put these down is, number one is going to be potassium iodide, so Ki. Number 2 is going to be sodium sulfate, which is NaSO4. The third one is going to be sodium carbonate, which is NaHCO3. And then number 4 is going to be phosphoric acid. Number 5 is going to be copper sulfate. Number 6 is going to be lead nitrate, which is PbNO3 with the NO3 in parentheses. And you're going to do the same through the vertical column as well. And this is going to set it up so that way there's a little fluidity in your table, and that way it makes it a little bit easier for us to go through and grade, so not everyone's is different. And what you're going to do is you're going to take these 6 solutions, and you're going to add each one together, and you're going to form some sort of reaction. And you're going to do that by mixing, for instance, potassium iodide with sodium sulfate, with phosphoric acid, with copper sulfate, and with lead nitrate. So you're going to do it with all of those. Then you're going to rinse out your test tubes, and you're going to repeat it, except this time you're going to say, all right, so we're going to add sodium sulfate to sodium carbonate, with phosphoric acid to copper sulfate to lead nitrate, and then you're going to repeat going down the list of each one of your solutions, so that way you've mixed them all together. Then you're going to go, and if nothing occurs, you're just going to write no reaction. And an easy way to do that is to just put NORXN, which is noted through the diagonal boxes of your table. So you're going to go through the rest of the lab writing out the molecular, the complete, and the net ionic equations for each of the reactions that only had one of those 4 signs of a reaction. So you won't have every one of them to do, because not all of them will form some sort of change in temperature, a change in precipitate, or a formation of a precipitate, formation of a gas, or a color change. So you're only going to have to do the molecular, complete, and net ionic equations for the ones that actually formed some sort of reaction. And then you're going to go through in the further questions, and you're going to go through each one of those, and you're going to finish those out. They've been started for you, and other than that, you're going to enjoy the lab. It's a fun lab. You get to see lots of cool reactions. The equations can be a little bit tricky, so if you're having trouble with them, just let your instructor know or your TA know, and I'm sure they'd be happy to help you out. So I hope you guys enjoyed the lab.